Hey Bio Team. So you guys learned in chemistry that molecules are in constant motion. They're constantly moving and bumping into each other. And so this allows for the process of diffusion to occur. The fact that molecules left on their own will naturally spread out. We say they move down concentration gradients from areas of high concentration to areas of low concentration. So examples of this would be smoke particles diffusing through the air. The particles would start highly concentrated, but over time they would spread out to areas of low concentration. Another example in liquid would be food dye diffusing through water. Now this is really useful in cells because it allows for passive transport. That is, it allows materials to diffuse in and out of cells naturally. That is, the cell doesn't have to do any work to move the materials just move themselves. And so there's two types of diffusion that will occur on cell membranes. There's simple diffusion, which occurs with nonpolar substances like gases or lipid steroids. And then there is facilitated diffusion, which occurs with charged substances. So for an example of simple diffusion, we have some oxygen molecules here. And so before diffusion, you can see that there is a high concentration of oxygen molecules outside the cell and a low concentration inside. And so during diffusion, the high concentration of particles will spread to the low concentration. And so after diffusion, we say that equilibrium has been reached. That is, the substance is now moving back and forth across the membrane at equal rates. Facilitated diffusion, meanwhile, occurs with charged substances. So here we've got some sodium ions. We've got a high concentration of sodium ions outside of the membrane and a low concentration inside. Now naturally, the high concentration would tend to spread to the low concentration, but in this case these ions can't diffuse through the lipid bilayer because they get repulsed or attracted, in this case, to the charged phosphate heads. So what a cell needs in order to facilitate this diffusion is a transport protein, in this case a sodium channel, and that's where facilitated diffusion gets its name. There's a transport protein that facilitates the diffusion, that allows the diffusion to occur. And so here, after facilitated diffusion, we can see equilibrium has been reached again. Now water is kind of a special example. Water can diffuse into a cell through simple diffusion or through facilitated diffusion. And this has to do with the fact that water is a polar covalent molecule. Water can diffuse straight through the bilayer through simple diffusion, but it tends to take a long time because it's a polar molecule and its partial charges tend to get stuck on the phosphate heads in the bilayer. We'll show that happening here. You can see the water gets slowed down by the bilayer. However, to speed up the process, what our bodies will do is create transport proteins. They'll synthesize channel proteins called aquaporins that allow water to diffuse through faster. And so equilibrium can be reached again, but through facilitated diffusion and the use of aquaporin proteins, equilibrium can be reached much faster. And that's it. At this point, you guys have some practice problems. We'll see you next class.